Welcome back to the Physics Review Podcast, where we break down key concepts from your lessons to help you master physics step by step. I'm Mr. Saavedra, and in today's episode, we are diving into the core ideas from sections 1.5 and 1.6. We'll be talking about precision in measurements, scientific notation, vectors, and much more. So grab your notes and let's get into it. Let's start with section 1.5, where we explored the world of precision in physics. First up, we tackled significant figures. Significant figures tell us how precise a measurement is, and every number counts, except leading zeros and placeholders. The more significant figures you have, the more precise your measurement is. But remember, we're not just measuring, we're communicating how confident we are in our results. Now, when reporting measurements, uncertainty is key. Every measurement comes with some degree of uncertainty, which is why we only report digits that we are confident in. For example, if you measure the length of a table as 2.45 meters, the 5 in that measurement is estimated. This uncertainty needs to be reflected in how we report our measurements. Next, we discussed units and scientific notation. Units, of course, are essential in physics. Whether you're measuring in meters, kilograms, or seconds, using the right units helps us quantify and compare different quantities. And when those quantities get really large or really small, think the distance to the sun or the mass of an electron, that's when scientific notation comes into play. Writing numbers like 1.5 times 10 to the 8th power meters helps to simplify things. Let's not forget prefixes: kilo, milli, centi, all those handy shortcuts we use to express powers of 10. Kilo means 1,000, milli means 1,000th, and so on. They make conversions between units much easier. And finally, estimation. Estimation helps you make quick calculations or sanity checks during problem solving. Being able to approximate answers gives you a sense of whether your final results are reasonable or way off. Estimation is a powerful tool, especially when dealing with complex problems. Let's shift gears and talk about vectors from section 1.6. In physics, a vector is a quantity that has both magnitude and direction. That's different from a scalar, which only has magnitude. Vectors are crucial for describing motion and forces, and they come in handy for calculating displacement and velocity. Speaking of displacement, that's our first key vector. Displacement is the straight line distance from an object's initial position to its final position, including direction. Remember, distance tells us how much ground was covered, but displacement tells us how far out of place the object is, and in which direction. So, if you take a walk and end up right where you started, your displacement is 0, even if you've covered a lot of ground. Next, we talked about velocity vectors. Velocity is a vector because it tells us not just how fast something is moving, but in what direction. You can think of it as directed speed. If two cars are traveling at 60 miles per hour, but one is going east and the other is going north, their velocities are different. Now, what happens when you combine different vectors? This is where vector addition comes in. When adding vectors, we use either the tip-to-tail method or trigonometry to calculate the resultant vector. The resultant vector is the single vector that has the same effect as the original vectors combined. Imagine pushing an object in two different directions at the same time. The resultant vector shows where the object actually goes. And this is where our review of trigonometry comes in. Trigonometry helps us break vectors into their components, usually into the horizontal, which is the x-axis, and vertical, which is the y-axis components. You can think of these x and y components as the legs of a right triangle. For example, if a vector is pointing at an angle, you can use sine, cosine, or tangent to calculate its x and y components. Once you have those, adding vectors becomes much easier. Alright, that wraps up our review of sections 1.5 and 1.6. Today we covered precision in measurements, including significant figures, scientific notation, and estimation. And then we dove into vectors, displacement, velocity vectors, and how to add vectors using trigonometry. These are key foundational concepts that will show up throughout your journey in physics, so make sure you understand them well. Thanks for tuning in to the Physics Review podcast. I hope this helps you as you study, and if you ever need to review the concepts, feel free to come back to this episode. Don't forget to subscribe and share this podcast with your classmates. Until next time, keep exploring the wonders of physics.